Hi everyone, good afternoon. I'm Kushi. I'm going to be your host for today, and today we are going to be having a very interesting talk on starting up in the manufacturing landscape. And for that, we have Ravi Teja from the manufacturing COE, who is going to help us understand how things are working in the manufacturing industry. Uh, the floor to you, Ravi. Hello.
Okay. Hi, Khushi. Thank you for bringing me out here. I'm really excited. I've run my own startup in past and really excited to speak about how we at Affine are doing running manufacturing vertical and building solutions around it, right? And how we can be helpful for the startup space.
That's great. That's good to hear. So, a very interesting talk we have on today. So, in the past, we have really seen a lot of growth in the manufacturing industry, especially for the AI applications. In fact, the AI part of it in manufacturing is expected to grow at a growth rate of around 28%, which is a lot. So, things are going great for manufacturing right now, but could you please shed some light as to how have we reached this point today? What has the industry evolution been like?
Sure, I'll do that. So, in most of the conversations, what I have, right,
Mhm.
Industry 4.0 or how the industry has come till this juncture. So I usually start off with this slide where I speak about what happened before in last few hundred years and last few years, and then how did we reach now, right? So quickly, I'll just bring my screen up. Let me know once you can see it. Right? Can
Yes,
you see
yes,
my screen?
yes, I can see your screen.
Okay, okay. So with the industrialization of happened in let's say late 1700s when Sir James Watt invented steam engine, right? And
Right.
then the process of industries and manufacturing took off, right? And then we have early 1900s when we started mass production of cars, and we had assembly line. Concept of assembly line was discovered by Henry Ford, right? And then we
Mhm.
started using electrical energy for manufacturing different products, right? And then industry 3.0, this is when computers came into picture, and we also kind of had our heads around robotic arms and how do we use that for different manufacturing processes. So we also reached a few automation pieces, right? And then we reach the time which we are currently in now, right? That is, we have mobile networks, we have AI, we have data coming in, and we have different manufacturing machines which are talking to these computing machines, and there could be a lot more efficiencies and production optimizations which could be arrived at, right? So this is what or this is where we have reached now, right?
Mhm.
And if I speak about what are the industry 4.0 components, right? So
Yes.
what you see on the top right are the 9 different components of technology which we use in industry 4.0. But
Mhm.
even before discussing that, so if I have to speak about why do we need these components, right? So what are the common industry challenges, right?
Mhm.
So to paint a picture of a manufacturing landscape, our manufacturing machineries or assets are on an average 15 to 20 years old, right? And
Mhm.
different machines in different manufacturing landscape are commissioned at a different point of time. So what that makes is assume you have a iPhone first version and you have a iPhone latest version, right? How do you make communication between these two things happen, and how do you make whatever applications you're designing for the consumers talk to both these devices, right? So those kind of challenges exist, and bringing in any new machine is a capex investment. These run into a few $1 million, and then breaking even over the time takes a lot of time, right? And
Yes.
then the opex piece, which is maintaining of it, running of it, is also very heavy and expensive, right? And then the complexity, right, in terms of the operational technology available right now, and if
Mhm.
you want to do anything else on top of it to bring more efficiencies, you have to ensure that all the complex systems are connected to your new systems, and everything is talking to each other in a seamless fashion, and there are no cyber security challenges which can prop up because of
Yes.
this net, right? Now there are these 9 components here, right? And
Yeah.
fine, we focus specifically on industrial IoT, that is Internet of Things, then big data, artificial intelligence, how do we bring in automation using these technologies, and we also work closely with all the major cloud providers to make computing seamless, right?
Yes.
And the outcome of these technologies is this, right? One is a seamless integration between data. Then we
Mhm.
build intelligence. Now intelligence could be from a very simple form of creating a simple dashboard where you can see your uptime, availability, OE, such kind of stuff, right? And
Mhm.
also there could be automation using more recent technology like a computer vision based technology where you automate a quality process. You can do all of that, right?
Yes.
What all of this gives you is improved productivity, reduces downtime, increases
Yeah.
uptime, right? Adds
Yes.
more to the bottom line, and gives a better customer experience at the end of the day. And in this world where the customer demands are so dynamic in nature, it makes sense for manufacturing as well as all the industries around manufacturing to be equally dynamic and adopt these technologies, right? So
Absolutely. Yeah. That's really interesting to know where Industry 4.0 is headed, what are the common challenges, and how is it that we are solving all these problems. Now, coming to a very interesting fact that I came across some time back is that manufacturing is estimated to generate about 1800 petabytes of data, which is a lot. So
yes,
they're going to generate this type of data every year, and it is way more than any other industry that we see: finance, retail, communications, and so on.
right.
And what it is doing is, I think it's helping solve a lot of complex problems in manufacturing and address problems that were previously not anticipated by any of the players in the market.
Mhm.
Now, of course, it has quite manufacturing as an industry has quite an interesting landscape. So, could you just explain what the current industry scenario is? How is this huge amount of data flowing within the industry? And what is this IT/OT convergence that we tend to hear a lot about, but a lot of people are confused about?
Sure, sure, sure. So let me start by saying that manufacturing has arrived a little late to the party of digital transformation, right? But it's better late than ever. Obviously, all the other industries where we have learned from the more latest technology providers, whether it's Facebook, Google's of the world, or even banking systems, right, fintechs of the
Mhm.
world, they've adopted these technologies beautifully.
Yes.
Now, in context of manufacturing, let me just show you some interesting slide in terms of what kind of data is generated. So what you see on your bottom, right, this
Yeah.
is a small scale industry which has a turnaround of around 1 to 5 cr per year, generates close to around 2 to 10 terabytes of data.
Mhm.
That's a lot of data which you can mine to bring in a lot of efficiencies in terms of improving performance, reducing downtime, right? And
Yeah.
as this industries scale over time, right? Now,
Yes.
typical industry is here, somewhere here, right? Which
Mhm.
is 500 to 10,000 cr kind of a revenue or a top line, and they generate close to around 100 TB data. Now, this all of this data is a pure machine data, right?
Mhm.
And the behavior can be modeled beautifully, right? When we look at Facebook or any other kind of data, this is human generated data, right? So there are always chances of quality challenges or errors, but in a machine, pure machine generated data, the models or the AI algorithms, when you build them, right,
Yes.
they actually are very true, and they're able to predict the behavior of these machines beautifully into the future, right? Now, what you
Mhm.
have on the top is this graph, right?
Yeah.
So at the very bottom are the machines which sit on the shop floor. Now this could be a CNC kind of a machine or a stamping machine, right, which generates data in a very millisecond kind of a fashion, right?
Mhm.
And it could be also your sensor data. Now sensor data could be your temperature, pressure, viscosity sensors, or any kind of different. There are hundreds and millions of sensors deployed in bigger factories, right? All of these generate data in millisecond or real time basis, right?
Mhm.
Now, as you go up the hierarchy, now
Mhm.
there are systems like SCADA, which is supervisory control and data acquisition, and there is MES, right? So
Mhm.
these
Yes.
move into few seconds an hour. So this data is rolled up, right, and used for executing your orders well, and you can
Yeah.
give orders to the machines from top of this hierarchy well, right? And as you go up the value chain, right, and
Mhm.
you hit your ERP, CRMs, which are your IT systems. Now here the data comes in hours or days, right? That is,
Yes.
what are the type of orders which customers are putting in through, and what is the customer interaction which is happening with sales reps, so on and so forth, right? Now if I have to go a little deeper on
Mhm.
how data flows in this ecosystem, right? So starting from here, this is how a factory shop floor or a factory ecosystem looks like. Now you
Mhm.
have machines which could be robotic arms, it could be CNC machines, it could be
Yeah.
other boilers and things like that. Usually these are all connected to some kind of PLCs. PLCs are
Okay.
nothing but small computers. They're called programmable logical controllers. So you
Mhm.
program them to control your machines, right? And then these PLCs are in turn connected to SCADA. So SCADA is nothing but supervisory control and data acquisition. Through this, you can control multiple PLCs and multiple machines at the same time. So one supervisor can have access to a SCADA through which he controls multiple machines. Now
Mhm.
this becomes an interface for the data to go up, and this goes and gets stored in a historian. Historian is just a fancy way of uh, putting together a database, right? And this is where all the time series data of all the sensors as well as whatever operation at machine level is happening is going in. Right
Mhm.
now, if we have to consume any of this data, first what happens is we have to ingest this, right? So we'll
Yeah.
create data pipelines. That is first level of data ingestion,
Mhm.
and make sense of each of these different tags, right? What
Mhm.
tag means what variable, or what does it mean with respect to machine. Then we take it to the next level. We put it in one kind of a data platform. Now this can be on-prem, or this can be on cloud. So if it is in cloud, it could be some kind of a data lake where we store this, process this, wrangle this, and create it in such a fashion that it can be consumed later, right?
Yeah.
For effectively. Now consumption can, again, as I said before, could be in form of dashboards or BI reports, or even more recent algorithms or AI pieces, right, which are
Yeah.
machine learning, deep learning, and then all of this can go back into your machine shop floor. Either
Mhm.
you give these dashboards to each of these users, either on their mobile phone or the HMIs which they use, and then if there are more recent techniques of model creation, right, then you can generate alarms that saying that, okay, your machine is going to go down in next 1 week, so take action accordingly, right? And
Interesting.
what I've not covered on the left here is
Mhm.
different IT systems which manufacturers generally use, right? It could be starting from a simple ERP. Now, ERP is one of the most used software which is used for resource planning or for enterprise resource planning, right? As in, how many orders have we received?
Yeah.
How are we executing it, right? And then
Yes.
there is MES, which is a manufacturing execution system. We can see how many lines do we have, what kind of OEE is operational efficiency, which speaks about how many, if let's say a machine has 1,000 uh, parts it can produce, but actually how many is it producing? Is it producing 700, 800, so on and so forth, right? Then there is QMS, which speaks about quality management
Mhm.
systems. So different quality processes, how is
Mhm.
it going? What is the rejection rate? What is causing more defects? And then product lifecycle management. So these are the different softwares which keeps throwing data. We converge this data with machine data, and
Mhm.
for this, there's a lot of work which goes on in terms of contextualization, as in, because your ERP data is more at a day level, right, or at
Yeah.
a weekly level, but your machine data is at a second level. So how do you ensure that these both data can be made sense of, right?
Yeah.
So that's one interesting piece which we do, and then obviously the consumption part comes takes over, right?
Yes.
Now I also want to talk a little bit about IT/OT convergence because you touched upon it,
Yeah.
right? So from the time, let's say around 1970s, 80s, right, when
Yeah.
we got computing devices, right,
Mhm.
and semiconductors, so our machines became smarter,
Yeah.
but they operated on a complete different technology, and it was more in silo than compared to our IT industry, right? And what you
Yeah.
see at the bottom is our IT industry, which is more
Mhm.
dynamic in nature. So there are a lot of disruptions which have happened relative to OT, and now what we see now is a convergence which is coming through, right, where
Mhm.
we are not seeing this two technologies with two different lenses, but we're trying to see it with one single lens, and ensure that we converge both our IT and OT departments in a way that it's best used. All the assets are best used in a best fashion, right? So that's on OT and IT.
That's good to know. Finally, some easy explanation to understand this whole concept without getting confused again. So, Ravi, we at Affine have been quite active in this space, especially
Mhm.
for manufacturing, and we have a plethora of experience and expertise that we have gathered over the years of our operations.
Mhm.
Can you just shed some light on our expertise in this particular industry?
Sure, sure. Let me do that. In fact, let me project my screen. Okay. So, so if I have to categorize logically all the work which we do, right? These are the
Mhm.
four main pillars within manufacturing. So first one is QMS, which is quality management system.
Yes.
So here, what we do is we automate quality management processes, or make it faster, or augment the current processes using computer vision.
Mhm.
So it's like if there is a surface defect, and there is a manual person who is right now checking these quality defects, it could be converted into some kind of a camera-based system, and there is an intelligence connected to this camera, and it can detect these defects much faster than what a human can, and then human is freed up to do much better jobs, and go at little higher levels and perform better, right? Second is anomaly detection. Now, as I was speaking, there are so many sensors deployed on the shop floor. Now,
Mhm.
at any given point, the sensors value could fluctuate, right? So, and manually, it's very difficult to identify why a sensor is uh, varying, and with respect to other sensors, if it is varying, what does that mean, right? So, with using machine learning models, we can make sense of this, and we can say, okay, this anomaly is gonna cause this kind of a failure or this kind of a disruption. So we raise alerts accordingly. Right? Third one is, now that we are able to identify different kind of quality defects, right?
Mhm.
How do I avoid those defects, right? So most of
Yeah.
these defects are happening because there's some inputs to the processes or to the machines which are little away from the ideal parameters. So we
Mhm.
identify those, and we kind of fine tune them so that these defects don't happen in first place, right? So that's one big area where we focus on. And I
Mhm.
also try to cover some work which we've done in these areas. Second
Yes.
one is predictive maintenance. So we were
Mhm.
talking about these expensive assets what we have at shop floor, right?
Mhm.
And it's very important and critical to monitor the health of
Mhm.
these assets, right? One is, how is it performing real time, and if there are any challenges. What we also do is, we go ahead and see what is the remaining useful life of equipment. If equipment has been commissioned 10 years down the line, how many
Mhm.
more years can it work perfectly well, and every year what is the performance is going to be, right? We
Mhm.
also tend to predict failures, as in the failure might happen in a week or a month, and we create work orders accordingly into the CMMS systems which maintenance teams usually use, that frees them up from scheduled maintenance, and they can focus on the parts which are critical and going to fail now. And this also frees up cash flow from the critical parts which they have to otherwise store in the inventory, irrespective of whether there's a failure going to happen or not, right?
Mhm.
So that's one important critical piece, predictive maintenance, which we work on. Third
Yes.
is production optimization, right? So how do we? So a lot of process industry uses blends of formulation. So how do we optimize this formulation so that our output is better, right? And
Mhm.
what happens is this production happens in batch processes. So how do we ensure every batch is consistent with respect to other batches, which is giving the best output, right? And
Mhm.
also, how do we ensure that energy is optimized, whether it's electricity, whether it's water, or any other form of heat energy? How do we optimize the use of it, right? And then the last piece is supply chain intelligence, but it's very critical now, right? And now
Mhm.
that in the COVID era, we've seen that all the supply chains are breaking, and it's very important that we have a good insights into what our supply chain is up to.
Mm-hmm.
there are two parts to supply chain. One is incoming supply chain, which is the raw material coming to the factory, and then the outgoing supply chain, which is finished products going out of the factory, right? How do we marry these two, and how do we have high visibility? How can I forecast my demand? Can I marry that with supply? How do I optimize my routes, transportation, so on and so forth. Right? There are so many things which we can do here, and we have already done a lot of work in this spaces. Now, while working in these all areas, what we've realized is in manufacturing solutions don't happen in silos, and they have to be integrated into shop floors, right? And what we do is we work with a lot of partners and even startups for that matter, which helps us integrate these solutions or make our solution wholesome in nature and solve the problems in a more complete manner, right? So that's one of the work which we do at Manufacturing Center of Excellence at Affine. And what you see at bottom here, right, are the
Yes.
industry focuses. So auto ancillaries is one of our main focus areas,
Mm-hmm.
and we work with a lot of auto majors as well as auto ancillaries globally. Second is CPG or FMCG business or consumables business.
Mm-hmm.
Again, this is a very dynamic business, so they have to adopt all the recent technologies to make the shop floor dynamic in nature as well. And third is metals and heavy industries, and especially now with commodities, especially metal prices going really high, we have a lot in digital transformation projects, and all the metal players showing a lot of intent in adopting these technologies. So we are very excited to be in this era where this change is happening, and we are contributing to some of it.
Great. That's really good to know. We have a quite an extensive expertise in this industry. So since we do have some time on our plate, can you give us some practical examples or use cases where we have actually applied this and we can give a better understanding of our expertise and how we are using it in day-to-day
Sure,
solution?
sure. Let me do that. Let me cover, in fact, one or two of these blocks here, and
Yeah.
let me show
Great.
what is the kind of work which we have done.
Yes.
Okay, okay. So this happens to be one of the work which we've done with a energy major. Right now, with so much buzz around renewable energy, and rightly so, with so much challenges in carbon footprint and global warming, there's more focus on renewable energies. And what we've seen is a lot of these renewable energy players are adopting these newest of technologies, right? So the business problem here was these wind turbines, right, which are or the wind energy systems are deployed in far off offshore, or even when they're onshore, they're away from domestic centers, right?
Yeah.
So now when they're deployed in such a far off places, uh, repair or maintenance activity becomes a challenge, right? And if there is a failure of a turbine, it can cause a lot of disruption, not only on the grid but also in terms of the downtime, right? Because they're away, and to reach there with a critical part, and generally the height of these machines are close to around 60 to 100 meters, right? So that's how tall they're placed. So you have to bring in a crane to lift that down and fix it. Right? A lot of time and energy and resources gets wasted in this. So what we did was, one, identify first what are the different components in a wind turbine which are causing failure, right? Now wind turbine looks very simple, but it has very complex operations in it. So this wind turbine, what you see, is connected to a low speed shaft first, and then a gear box is connected to it, which converts this low speed into very high speed, which is useful for current generation eventually, which is in turn connected to a generator where the actual current generation happens. Now this power or energy which is generated here is sent to a transformer, so that you step up the voltage for the grid transmission, right? Now these are some of the components which I spoke of. Now under these components, there could be multiple components again which could fail at any given point. So first what we did was we analyzed which are the components which are causing downtime, and which of them are causing the highest downtime, right? So we identified top three components, let's say, and then we built predictive models which could say, because of this particular variation of data, this particular component might fail, right? Now what kind of data did we analyze? We had power sensor data, we had wind speed data, we had external weather data, we had oil temperature data of a gearbox, right? what was the voltage and current fluctuations happening at the power generation, right? So we had all of this data. This ran into terabytes, and we first consolidated them, created predictive models out of it, and we were able to generate alerts for the maintenance teams to come and fix these products at the right time and right place, so that there is one the kind of business benefits which we could leverage out of it was we lowered the machine downtime, and that definitely caused efficiency, improved efficiencies and more uptime, right? And also it caused a better output towards the grid, because there are lesser disruption and we're using the resources better. So obviously it helped to increase the bottom line as well, right? So this is one of the work which we've done in predictive maintenance space. Let me speak of something in production optimization space. So what you see here is the work which we've done with the integrated steel plant. Now, creation of steel, there's a blast furnace which is used, and I'm sure most of you would have studied this in your high school science, right? There's a blast furnace and there is a coke which is used as a fuel for this blast furnace. Now, the problem here is, or the business problem statement is this, right? The coke is created using a different kind of coal blends. Now, these coal blendeds are imported as well as domestically available. Now, imported coal, some of them are of high quality, and they have few better chemistry parameters, which makes them give them high calorific value. Now, when we blend them with domestic coals, we try to optimize it, one for quality and one for cost. Right now, the challenge here is how do we arrive at these different percentages of coal and how do we blend them, right? We created using historic data as well as the process parameters of these coke ovens, and created optimized models which could help the operators decide, simulate, right? If you have four types of coal available, in which different proportions do you mix them, which can result in the desired quality, but at the least cost possible, right? Now, one is this helps the operator who is making this coke. Second is it also helps the procurement team, right? Because coal being a commodity, the prices of the coal keeps changing, right? And even if the coal prices or the commodity prices are protected by long-term contracts, a lot of high variations in commodity can cause a lot of disruption in procurement cycles, right? So
Yes.
this gives some kind of intelligence to the procurement team on which coal can they procure based on different requirements they have received from their vendors, right? And at what cost, and which will result in a least cost and best quality output, right? So now we created the simulation engine and we kind of worked with the client to deploy it. Now there's different kind of data which is used for this. There is LIMS. LIMS is nothing but lab data, right? And then there is MES, which is consumption data, how much coal is being consumed for producing this coke. Then there is process data on what temperature is this coal baked at, right? What kind of temperatures variations are happening. And then there is obviously pricing or the procurement data which comes from ERP. So we combined all of this data together, created some kind of analytical data set, created artificial intelligence algorithms which could work on top of them, and then created a beautiful simulation engine. And this helped in multiple things for the business. One is it saved them cost for raw material blending and procurement, right? And also empowered operation team with simulation tool, before which they had to go to a pilot or coke oven all the time. But yeah, this helped them optimize this process as well.
Great. Wow.
Right.
Like these are things that you don't even think about unless you are working in this space. And even then, this is not something that really is on the forefront of someone's mind. But great, like these applications are very interesting. And what is a really, really good part is that people like the startups we have at Deep Camp, our accelerator program, they get to have mentorship hours with you if they are in this manufacturing space. And I'm sure you will be providing a lot of valuable inputs to them that will help them with their startups.
Yeah.
So you want to say something to future Deep Campers?
Sure, definitely. And what I've seen at Deep Campus and the kind of applications which we've received in different domains, focus domains, right? It's very exciting. Looking forward to work with some of them. And also, what I want to say is, running a startup is not a very simple job, right? So there are a
Yes.
lot of hats which you have to keep juggling, right? So we provide, starting from mentorship, which is we have a lot of experience on dealing with enterprises or mid-market consumers, right? So we
Yes.
understand their pulse, as in what do they want, right? What problem are they solving, and is that problem aligned to the problem which you're solving, right? And what kind of solutions do they really buy in? And is your solution doing the complete job? If not, can it be married with some other solutions and made into a wholesome solution, right? Eventually.
Yes.
So these kind of calls uh, uh, can take with the startup. We can guide them, right? Not only in terms of
Yes.
mentorship, but also giving them a good understanding of what the market is, right? We were
Yes.
speaking about manufacturing, but within manufacturing also, auto player is very different from a steel player or any other metal player, right? And
Yes. Yes.
definitely a biscuit manufacturer is very different from a grain packaging guy or a supply chain guy, right? So we have a very good deep insights into how these markets operate, right?
Mm.
We understand the pulse of the customer, what they're buying, and at
Yeah.
what price point are they buying, right? And we
Mm.
also help with seed money so that your OPEX or the cash flow challenges are taken care of, right?
Yes.
And we have a lot of senior leadership who have run startups and part of Affine now, right? Who can
Mm.
guide you in what they have done, what they have learned from this startup journey, and we would love to give you that guidance. So
Great. Thank you so much. So this is for all the startups out there who are building solutions using AI, ML, and cloud. If your focus domain falls in any of the four that we have listed below, which is gaming, media and entertainment, manufacturing, and social impact, you can apply to be a part of our accelerator program at www.affine.ai. You can get all information about the program on our website, or you can always reach out to us on our social media platforms as well. So thank you so much, everyone, for tuning in. Thank you so much, Ravi, for this really informative live session. I am sure everyone had as much fun as I did.
thank
So
you.
thank you so much.
Thank you very much.
Bye.
Bye.